Hold it. As you go through the notes, make sure you find answers to those questions, okay?
Yes, sir.
Shall we begin?
Yes, sir.
Shall we begin?
Yes, sir.
Hide your phones. Let's go on. Now, arguably, fossil fuels, you have to listen up. Now, I'm no longer angry. I was angry.
Thank you, sir.
Now, the next thing that can make me angry going forward is you guys not paying attention. All right? Arguably, fossil fuel has revolutionized the globe worldwide. Right?
Yes, sir.
So, when you talk about industrial revolution, what does that mean? What does that mean?
It means our transition into the use of coal and fossil.
Into the use of coal and, natural gas, oil, and all of that, right? Not only that, it has changed the way we do agriculture.
Yeah.
All right? What else? What else?
Transportation.
What else? Domestic use. All right? So you can see that coal has simply changed. Man, why are you laughing? With your cap. This man, yesterday I noticed your cap. Today, you are using your cap to distract me again. Okay, like I'm a joker, right? Okay. Is that it has totally changed the way we live, right? But having said that, it has also brought about pertinent discussion about what? Climate change.
Yeah.
Are you there?
Yes, sir.
What about what other stuff? What other discussion are we talking about? Climate change, which is sort of climate change is kind of different from global warming. It's different from, so it's all under climate change. All right?
Okay.
Climate change, energy security.
Yeah, it's eventually finished.
Say again?
Like, it's eventually finished. I mean, it might run out. It might run out.
Absolutely. That's energy security.
Yes.
Three things I want to mention here. The first one is what? Climate change. The second one is what?
Energy security.
And the third one is energy transition. Are we still together?
Yes, sir.
So, in other words, we're saying fossil fuel has totally changed the way we live. But it has brought up discussions about three important topics. Number one, climate change. Number two, number three. All right. Are we there now?
Yes, sir.
All right. That's a way of introduction. Having said that, this is the learning objective. Number one, define fossil fuel. So to those your questions, add all of this because you're going to see them in your exam. And you don't need to repeat the question twice. I already told you to differentiate renewables. Do not take it. This man, or you go out of the class because and behave yourself. Okay. There are two categories of natural resources. The first one is renewables, and the second one is non-renewables. What's the difference? Renewable, basically, you can, get it to form within a short space of time. It can be replenished quickly. Non-renewable takes a very long time, millions of years to form. What are the examples of renewables?
Flowing water.
So solar, wind, crops, water, hydro. All right, you can get them to form, within a short space of time. In fact, within the human time scale. But non-renewable, it takes a very long time. What are examples of that?
Fossil fuel.
So if you didn't know, now you know. It takes millions of years to form. All right? Two categories of what? That instead of you to pay attention, this man, and this other man.
Yes, sir.
You see, they will isolate you, distract from this point. Let's go. All right. Where are we now? I wanted to put this here because although it's a little bit outdated, but it hasn't changed much. And what does this mean, really? We're talking about the energy mix in Nigeria, right? So, for instance, although we have an enormous amount of hydrocarbon, in our subsurface, especially from Niger Delta. But there are other energy resources that we deal with. For instance, we've got coal, we've got hydro, we've got wind and solar, and then biofuels and waste. All right? Now, in terms of energy, we have about 6,000 terajoules. That's enormous energy. All right? Enormous terajoules. All right? Now, in all of this, biofuels and waste make up an enormous percentage, about 74% of that. We're talking about Nigeria now. Okay? What does that tell you? Although we have an enormous amount of oil and gas, but we depend more on what?
Biofuel.
What is biofuel?
Yeah, from the they are formed from biological waste.
Write it down, write it down. Write it down. It's part of your question. Write it down because some of you are looking lost. Like, what is biofuel? Firewood, charcoal. Right? So, although we look as though we've got lots of resources in terms of hydrocarbon, but that tells you that there's lots of, people living on the class. We still make use of charcoal. We still make use of firewood. We still make use of, things that. So we're not living like, I'm looking for the word. We are living below par. All right. So we still rely heavily on biofuel and waste materials. Okay. When you say waste, for instance, dumps. All right, and all of that. Good. Now, if you think about, I've shown you this already, but this is in a bar chart, so you see the percentage about 74.5. And in terms of consumption, all right, again, because we have more of biofuel and waste, we rely heavily on it. We consume more of that, right? So there's no more disparity in that. Okay. What do we really spend all of this energy doing? We spend it especially in commercial and public services. Mm-hmm. So you see there's consistency. Yeah. Commercial, like we use firewood for day cooking and all of that. So we still have lots of, unimproved areas, villages and all of those places. Okay, as compared to rural areas as compared to urban areas. Okay, so that tells you that we still do a lot in terms of commercial and public services, consumption of biomass and waste. Look at the other energy resources; they are way low compared to what we consume. Okay. Now that just to kind of give you a heads up about our situation. If you went to a Western country, all of those graphs will change. All right? Now, what is fossil fuel? Fossil fuel are natural energy-rich substances that form from the remains of living organisms. When we talk about living organisms, we basically refer to plants and animals. Okay? Remains. So basically, when they die, they get buried, they become organic matter, and with further burial, they begin to transform due to what? Increased heat and pressure. All right? Are we still together?
Yes, sir.
Fossil fuel. Fossil fuel. So basically, we still make use of this ancient source of energy, okay, that had been beamed from the sun. All right? And that takes us to the next slide, paradox of fossil fuel. Do you know what this means? Do you know what a paradox means? Do you know what a paradox means? Doesn't make sense, right? Who agrees with him, though? What's a paradox?
Like a contradiction.
Contradiction, right? Who else? The ladies that read Nobel, then the ladies that read Nobel as well. We're talking about fossil fuel as a paradox. Alright? What that simply means is that although it's broad development, okay, but it's still a pain at the end of the day. Alright? Development in the sense of what? In the sense of what?
Energy
Okay.
supply.
Energy we need it for our day-to-day life, right?
Yes,
So I
sir.
say pain in the sense of climate change. Okay? And all of these lie in the fact that when we say we need it for our day-to-day life, if we think about how we need it for our day-to-day life and how it becomes possible, we take carbon from the atmosphere. So if you think about photosynthesis, what is photosynthesis?
It's a process by which green plants convert the sun energy with carbon dioxide.
Only one person. What class is this safe? I don't understand this set of people at all, man. I really don't understand you guys, man. If you're bold enough, you show by raise of hand, and then I'll ask you to speak. Talk to me, please. And water, right? So we use in the presence of sunlight, we take carbon dioxide from the atmosphere, all right, and we combine that with water. At the end of the day, we produce what? Starch. There's a reverse side that is what? Oxygen. We produce oxygen, right?
Yeah.
Now, plants, right, make their food like that way, right? And then animals feed on what? Plants. Right? At the end of the day, when they die, what happens? What happens? They become what? Organic. They decompose in the absence of what? Oxygen. All right? And what happens? What is the product? Carbon. Carbon is sent back to the atmosphere. All right? So essentially, you're looking at a carbon cycle. Are we still together?
Yeah.
When they decompose, carbon is sent back to the atmosphere. All right? Then, if it's not sent back to the atmosphere, what happens? It gets buried in rocks, even deeper and deeper. What happens again? The oil companies you are thinking about joining in 3 years to come, you are about in what 200 level. They go and they start finding hydrocarbons trapped in rocks. If they're successful, what happens? They begin to extract. What happens again? They begin to burn and they send it back. Gas flaring back there. So that's why we say it's a paradox. Are we still together?
Yeah.
We take it away from the atmosphere to develop. Right? Our day-to-day lives. You've already said it, industrial revolution, transportation, agriculture, you know, all of that. I did to the commercial stuff, right? At the end of the day, haven't taken it from the atmosphere, we send it back in. And that is why fossil fuel becomes what? A paradox. Question number whatever. Explain fossil fuel being a paradox. Are we still together?
Yes, sir.
Do you understand this? Shall I drive? Okay, so 2 slides have covered that already. I think I need to be close to my laptop to move this. All right. Okay. So read it to make sense, right? What are the types of fossil fuels? There are 3 types. Number 1 is coal. Number 2 is petroleum. Number 3 is what? Natural gas. There are 3 types. Did I ask you that question before?
Yes, sir.
All right, so you have answers to that, right? So what we're going to do now, the most important thing about this is that for all of this, you've got some sort of carbon and hydrogen in combination. All right? And this is very important. When fossil fuels are formed, all right, the CO2 and the hydrogen that went into them is removed from the atmosphere circulation. All right? But when it is burned, what happens? They will return back. That is the paradox we're talking about. All right? There are 3 types of fossil fuels. Number 1, coal. Who's seen coal before? You guys have been to the field? Are we taking you guys to the field?
Yes.
Did we show you the coal?
No.
Okay. Anyway, we don't go to the east anymore. But normally we go to Enugu, but because of insecurity and all of that, we won't go there anymore. All right. No one wants to be kidnapped, right? Yeah. But if you've seen real coal before, you're going to appreciate the next couple of slides, right? So this is what it looks like. It's really, really light, depending on how mature it is. All right? The more mature, the more lighter it is. All right? It's not as heavy as your rock sample. All right? All right, let's move on. How does it form? You find coal in swampy environment, forested, swampy environment. So they form from dead plants. Remember what? Dead plants. Did I mention animals or organisms? No. They only form from dead plants in swampy environments. The other thing is that when they now die, they get buried and then they become organic matter. And then from there, they transition into what we call lignite. And then they move on, greater barrier and temperature, right? They become bituminous coal, all right? And ultimately, they become anthracite. And then the finest grades become what we call graphite. Are we still together?
Mm-hmm.
Are you guys learning anything new?
Yes,
Yes, sir.
Are you sure?
Yes, sir.
Remember, don't throw your sheet of paper with your matric number on because this might just be your considered assessment at some point. All right. Good? You learning something new, right? All right. Okay. So we talked about coal, how they form, right? We said it's one of the fossil forms, okay? And we also talked about the fact that, with increased burial, temperature, and pressure, they transition from one form to another. The finest grade being what? Graphite. Okay. Now, this is what it looks like. You can see this is a forest, a swampy forest, okay? And the first part is peat, lignite, bituminous coal, okay? Anthracite, and then graphite. You can see it in reality. You see, it's fibrous when it starts off. Right? Fiber-ish. All right? And then you begin to go into something that is more refined and then lighter. Okay. In terms of distribution, okay, there are two classes. The first one is Carboniferous, all right, and Cretaceous. So these two times, they stand out because the conditions were favorable as at that time for coal formation. All right? If we take Carboniferous, for instance, okay, it had to do with the Earth's climate. It was warmer and humid, okay? And that was widespread in tropical swamps. In the Cretaceous, what happened was we had the breakup of Pangaea. So what happened during that time is that we then had the formation of large inland basins when the southward portion of Gondwana, of Pangaea, which is Gondwana, broke up, forming inland basins that had conditions that were favorable for the formation of coal. So, horse, two classes in terms of distribution. We had huge amounts forming in Cretaceous, and at other time, Carboniferous, they had under huge amounts formed as at that time. So anytime you see coal as a source rock, all right, for hydrocarbon, all right, they must fall into one of these classes. We see together. All right. Global distribution. You can see them on the screen. I don't need to talk much about this, okay? But what is important is that in terms of supply, okay, planetary reserves, you're looking at about just 1,000 gigaton, okay? But what we consume as of 2023 to 2024 is about 4.32. I think round about now, we're looking at about 8 gigaton. And that is expected to climb as we even go on, all right, up to 2030 and 2035. Okay? The bottom line is that there will be realistic growth models suggest that there's a less than a century left for our reserves. What are reserves? Reserves are the ones that have been economically confirmed. Okay? Economically confirmed. That is reserve. All right. What are the cons for coal? Extraction. Have you seen where coal has been extracted before?
No.
We can do open mining, open pit, we can do subsurface, and I can tell you for the fact that the extraction of coal is not environmentally friendly. Okay? You degrade the environment on a wide scale. The other thing is that the waste, the tailing ponds from coal extraction can be really, really environmentally harmful if they are not properly managed. All right? Because if the pond breaks loose, okay, you're going to have serious contamination of the land, okay? And not only that, even if you manage it properly, if you have residents that are adjacent to where you extract for coal, okay, you might have problem with groundwater contamination. Are we still on the same page?
Yes, sir.
All right. So these are the cons, all right? The other thing is acid rain. Acid rain, okay? What is acid rain, basically? So when you extract for coal, all right, what you do is that sometimes you get, so a major component will, this droplet of sulfuric acid from the coal, all right? So when you get sulfuric acid combined with rain, you get acid rain. When that gets into a body of water, what that does is that it increases the acidity of the water, which is not good. Do you remember our pH scale?
Yeah.
You know the pH scale?
Yeah.
What is 7? What is 2?
Acidic.
What is 14? Yes. Basic. Now, when you have more acid come into the water, what happens? You tend towards what? The right, which you don't really want.
The left.
What? The right. Left is acid now, right? Go. Sorry, yes. So, yes, left. Yeah, you're right, I'm wrong. So, you go towards what? Acid. Now, what do you think fresh water, where do you need to be in terms of pH? 7. A little bit less than 7, yes. Yes.
6.5.
Yeah. So what you want is you want fresh water, but when you begin to have water that is more acidic, it could be dangerous for our lives. Are we on the same page?
Yes, sir.
We're talking about the cons for what? Coal extraction. Are we still together? All right. When did we start this lecture? After 4, right? All right. What does that put your eyes on? Having some kind of red eyes, yeah? It's something for us, okay? Okay. How do you feel now when you left out your guy? Good? Are you following? All right, you want to go back there? No. You've been delivered, right? How about you have to think about your life? All right, let's go on then. Okay, now, petroleum. What does that even mean? So we've talked about coal. So petroleum, they are naturally occurring, okay? They are flammable with liquids. And the most important thing you need to take out of this is that it's a complex mixture. Complex mixture, all right? You have small amounts of other elements like sulfur, nitrogen, and oxygen, all right? And oxygen. How does it form? Unlike coal that forms from the remains of plants, for this one, it forms from the remains of organisms. Organisms, all right? What kind of organism? Algae, okay? There are different types depending on the environment. These are the kind of environments, continental shelves, river deltas, and inland seals. So this is a typical type you're looking for organism that will form hydrocarbons. All right? Now, for you to get hydrocarbon formed, you want all of the elements of the petroleum system to be in place. What are the elements of the petroleum system? You start off with source rock, reservoir rock, a seal rock. All right? You need a migration pathway, and then you need a trap. 5 elements of the petroleum system. And that is when you're talking about a conventional petroleum resource. Conventional because that's what we should expect. Are we on the same page?
Yes, sir.
All right. So I've mentioned the elements of the petroleum systems, right? Most importantly, when we begin to look for petroleum or hydrocarbon, if you like, as a petroleum geologist, what you look out for are traps. There are 2 types of trap, basically: structural traps or stratigraphic traps. When you talk about stratigraphic traps, there are 2 types of trap, basically: structural traps or stratigraphic traps. When you talk about stratigraphic traps, you look at what? Pinch outs or unconformities in the subsurface. When you talk about structural traps, you look for folds, faults, or subducts. Are we still together?
Yes, sir.
I'm not dwelling on all of this because that is not the focus for the class. We're just talking about how we find and what we look for when we look for petroleum. All right?
Yes, sir.
2 types of traps: stratigraphic and structural. All right? How do we find this out? We look at this using geophysical tool. All right? We can think about seismic, electrical methods, or gravity, but let's stay with seismic because that is the most popular way we look for hydrocarbons. Seismic data. For you to shoot seismic data, you need 2 things. You need a source, right, on the surface, and then you need receptors at another end. Because when you shoot that source, energy source, like a seismic wave, it bounces off underlying layers or reflects, all right? And those reflections are recorded by geophones or hydrophones, depending whether you're on land or you're on water, all right? Now, you take that information, you take it to your processing center, and then you come up with the seismic data. And then geologists will hold that seismic data and begin to interpret surfaces, faults, and all of that to come up with prospects, places where there are potentials to find hydrocarbons. Okay? So for instance, you can see how the energy has bounced off this fold that contains reservoirs that could potentially contain oil and gas. If that is interpreted correctly, it will be shown on a map. And then that's what you chase as a petroleum geologist. Okay? Talk about that more when you get to, I think, 400 level. 400 level, right? 300. You are currently in the, what, 200 level?
Yes.
All right. So, I mean, for those of you who could be interested in this, you begin to hone your skills towards, all of this. And there could be a potential reward depending on how smart you become as you transition these levels. All right? As you all know, in previous times, we've got students that have represented us in competitions, both nationally and internationally. And if you do very well, you could represent the university and Africa at the global stage. Are we still together?
Yes, sir.
All right. Currently, we have 5 students representing us next month in Houston in the IBA AAPG Global Finals. All right? And stuff like this, whilst they were in 200 level, spawned their interest in petroleum geology. All right?
Yes, sir.
But it's not automatic. You have to begin to develop interest, all right, and show that you actually know what you're doing. Are we still together?
Yes, sir.
That's just a digression. All right. Now, I've not lost my train of thought.
We're still talking about the reservoir and parts and the
Yeah, so that is conventional hydrocarbon, right? Because you have the source, the source rock, the reservoir, the seal, and all of that, migration pathway, and the trap, right? There are times where you don't have a seal and the hydrocarbon migrates to the surface. When it does migrate to the surface, what happens is that the volatiles will eventually leave the rest of the substance behind. All right? And what you eventually get is what is known as bitumen. Bitumen is different from tar sand. Tar sand is the entirety, both the sand and the oil. Bitumen is the oil. That is viscous. Are we still together?
Yes, sir.
Do you understand this transition? If you don't have a seal, hydrocarbon will migrate to the surface, and then it loses the volatile component, and it becomes heavy. All right? That heavy hydrocarbon is bitumen. But it's not just hydrocarbon on its own. It's hydrocarbon with sand, clay, and all of that. All of those components is what we call tar sands. Exam question. Differentiate between tar sands and bitumen. Your sheet is not full yet, is it? All right. Where are we? So you see what oil sands look like? Oil sands is also tar sands. But we are saying it's different from bitumen. All right? Bitumen is the oil that is highly viscous. Okay? Tar sand is everything put together. All right? So sometimes the term tar sand is used to describe bitumen. But what? That is not true. It's not correct. Okay? Bitumen looks like tar, but it's a naturally occurring substance. Are we see together? All right. Note that, please. Very important. When you talk about the distribution of hydrocarbon, you find most hydrocarbon are located in the margin of the ancient Tethys Ocean. Tethys Ocean no longer exists. It does exist before, where we had the breakup of Pangaea. So the ocean that bounded that separation between Laurasia up north and Gondwanaland down south was called the Tethys Sea. But that has now been shut off. And then the environmental conditions through time has favored the formation of petroleum. So countries around those regions, such as Kuwait, Saudi Arabia, Iraq, and UAE, they hold a vast amount of hydrocarbon. We see together. So tomorrow when you're asked, why do you have lots of hydrocarbon in UAE? You should know why. We see together. Are you guys learning anything new?
Oh, yes, sir.
Are you sure?
Yes, sir.
All right. Question, next question. Why do you have this time? 10, 12, 18. Wow. We only have petroleum concentrated in that region. There are other places where, you see runner-ups, they are listed on the screen. Okay, so it's important to take note of all of that. Okay, now, here is a world map, right, that shows us not the present configuration of the continents, but what you see here is about 225 million years ago, where we had the breakup of Pangaea. And we have Gondwanaland, and then we have Laurasia up north, and we have the Tethys Sea that does separate both supercontinents. And we're saying that we have lots of concentration of hydrocarbons around this region. All right, because the conditions, as at that time and over time, has favored the generation of what? Hydrocarbon. All right? All right. Please take notes. Very important, okay? What are the pros of petroleum? They are concentrated deposits. They are easy to transport and store, okay? And they are not horrifically toxic, okay? What are the cons, though? Again, goes back to climate change, greenhouse gases, thrown into the atmosphere. You've got environmental risk, especially doing transportation, exploration that could be easily managed, but when you try to transport, there could be leakage of pipelines, there could be accidents for trucks that are moving tankers and all of that. That could be a con. And then the other thing is political issues. For instance, if you follow the news, what is currently happening along the Strait of Hormuz? The war, right? What is today's price for a barrel of crude? Today's price. What do you guys use your phone for? What do you use your phone for? Say again? 15K.
What is that?
Fight between Iran and they are stopping, they are putting a hold to it. That decreases the price of crude. If you say there's going to be a fight, it increases it, and that affects the stock market. Are we still together?
Yeah.
It's not just from your dada to this place, back to dada, back to football, back to sports center, back to your girlfriend's house. You have to think widely, right? Get serious in your life. Between all of these valued minerals and ions, metals, and all of that. Okay? Uranium. Anyway, the one is enough for the wise. If you understand what life talks about, you're going to stick to one and you're going to run with the information, right? So people are tired there, they are just, If you want to go, you can go. The class is over, you can go. Who wants to go now? Who wants to go? You want to go? You good? You want to go? You can go, the class is over. All right. If you want your life to move forward, stay. All right, let's begin to wrap up. So we're talking about cons, we're talking about political issues. It's important to know about two factors here, all right, because what happens to the future depends on two factors, and those two factors has to do with the resources, all right, what we know exists, and then what is economically extracted or viable. So that is defined as what? Reserves, and then the resources are what we know exists. Okay? Those two terminology will go a long way to define the future for petroleum. Okay? There's also what we call peak oil. All right, where is that? I think it's on the next page or something.
Is your laptop go?
All right, there's peak oil. I think my battery is running out. Let's just quickly run through the last one. Now, the last one, I'm not going to speak much on it because what happens is that when you extract for hydrocarbon, what happens is that most times you're going to get oil and gas. And natural gas is when you have more of gas being produced as compared to oil. All right? But the formation process is entirely the same. The only difference here is that with gas, they are primarily produced from dead plants. All right? As compared to oil. Depending on the kind of kerosene you get. Kerosene is the precursor for hydrocarbon. All right? There are type 1, type 2, type 3 kerogenes. All right? I know you don't need to know in detail about all of this at this time for this course. All right? But just know what all of that means. Okay?
Yes, sir.
And then the other thing is that with natural gas, we find abundance natural gas in unconventional. So when we talk about unconventional, another name for that is shale gas. Who's heard of shale gas before? Shale gas. Shale gas. Shale.
Because he said sedimentary rock.
No. We're talking about gas, right? And I'm saying you find abundant gas in shale gas. Now, the shale gas is unconventional. Remember, I've been saying unconventional, right? I've been saying conventional, right? But with unconventional, what happens is that you don't need to have the source being shale, reservoir being sandstone, seal being shale. You don't need a trap. You don't need all of that with unconventional. With unconventional, the source, the seal, the everything is in shale. The shale formation holds all of these elements. Okay? But again, you can extract it the usual way you extract for conventional. So what you have to do is on the next slide. You have to frack. You have to send pressurized fluids into the subsurface to break up the rocks, right? So that they're able to flow into a producing well. Are we see together? And that's exactly what you see on the screen. Okay? You send fluids down, okay? The fluids go back in, into producing facilities on the surface. Okay? Pressurized fluids. What you're trying to do by fracking is that you break the tight rocks, create artificial fractures that will aid migration of the gas up to the surface. All right. And then there's what we call hydrates. Okay? This is sort of a potential future energy source. Potential future energy source, otherwise known as methane hydrates. Okay? Don't dwell too much on this. I probably will not ask you questions. There are other alternatives. Uranium future, right? 235. And basically all you're doing is that you're breaking up, okay, the uranium nuclide, and you're releasing amounts of energy. All right? And that energy is being exploited for our use. Okay? You see, I'm running out of gas now, and we need to finish off right now. The other point I need to bring up to your notice here is the pros and cons. I don't need to, you have the notes, so read up these ones. Having said that, I need to make mention of the fact that this is highly toxic. All right? It's highly toxic because, when you have a major incident, then there's really a problem. For instance, in 2011, when we had an earthquake in Fukushima in Japan, what happened was, it blew up a nuclear power plant, and that was really harmful. And that's the example there in 2011. I don't know how many of you did watch the news then, but I think I saw it. Yeah, this was the case then. So when there's a problem, then there's really a problem. Okay? So those are the cons. And the other point I need to raise here is the fact that you've got other renewable sources, for instance, solar. Okay? You see, I'm not dwelling on all of those anymore. There are pros and cons. The point we want to finish up now with this is, why non-fossil fuels are expected to account for half of the growth in energy supplies over the next 20 years? The outlook projects that oil and gas, totally with coal, will remain the main source of energy. Did I ask you this question? Did I ask you this question? All right, good. We know that it's going to power the world's economy and account for about 75% of the total energy supply as of 2035. All right? Are we still together? All right, so take note of that. The other thing I need to show you here is that here, again, is a credible source as of 2017. I don't think that has changed much. All right? This is primary energy consumption by fuel. Okay? You've got both renewables and non-renewables on that. Okay? Primary consumption by 12. Shares of primary energy. What's going on here? You can see oil and gas, okay? Oil and gas and coal, you can see that we're consuming more of that compared to the rest of the energy sources, okay? And then from the last few decades, from 1965 to 2035, we are projecting that our over-reliance on fossil fuel will in fact reduce. And then renewables, okay, looks like it's having an upward trajectory. Are we still together? It's probably projecting an upward trend.
So do you get this from
Say again?
that thing? This is it from the EM simulator?
It's from a credible source. Yeah. BP 2017. Okay, British Petroleum. All right. So, what are the points to take home here? Final thoughts.
Final thought.
Number one, petroleum originates from organic rich source rock. Number two, a complete petroleum system is required, okay, for that to happen. Complete. I gave you 5. I don't know what the 6th one is. I gave you 5 though. Right?
Source rock, reservoir, migration path.
Hydrocarbon exploration is fundamentally geological, and I showed you, what that meant. Okay, source rock and all of that. Number 3, natural gas and unconventional, including methyl hydrates, are increasingly important components of the global energy mix. All right? And then fossil fuel remains indispensable to the global economy, but they are finite resources. They are what? Non-renewable. And then, as future geologists that you are, your role extends beyond finding oil and gas. You must understand how Earth's geological history created these resources, how to locate them responsibly, and how to contribute to sustainable energy future through sound scientific and environmental practice. That brings us to the end of the lecture. Any question?
I'm coming there.
Talk to me, please. 5 elements of petroleum system: source rock, reservoir, seal, trap, migration pathway.